Idiopathic Pulmonary Fibrosis, or IPF, is a progressive and fatal form of chronic interstitial lung disease that eventually leads to the destruction of lung architecture and ultimately respiratory failure. The exact mechanisms by which IPF occurs remain unknown. Early hypotheses suggested that this devastating disease was caused by chronic inflammation that led to fibrosis. However, an increasingly favored hypothesis suggests that a still unidentified stimulus or stimuli produces repeated injury or insult to the alveolar epithelium, followed by an abnormal repair response that leads to unremitting fibrosis. Let's take a closer look. Despite the unknown etiology of IPF, several potential associated factors have been identified and include genetic predisposition, smoking, environmental dust exposure, gastroesophageal reflux disease, oxidants, and viral infections. The specific sequence by which the pathogenic mechanisms of IPF occur remain poorly understood, but are currently believed to begin with repeated injury to either the function or structure of alveolar epithelial cells. Once injured, the activated epithelial cells stimulate the release of several profibrotic and inflammatory mediators, including transforming growth factor beta and tumor necrosis factor alpha. TNF-alpha and other cytokines mediate recruitment of inflammatory cells, while TGF-beta and other growth factors stimulate the migration and proliferation of fibroblasts, which begin deposition of collagen matrix to initiate the repair process. Growth factors are also believed to play a role in the emergence of myofibroblasts from resident cells. Over time, these cells organize into clusters known as fibroblastic foci, where they continue to deposit extracellular matrix. The healing process becomes uncontrolled and dysregulated as matrix accumulates and the fibrosis becomes established. The dynamic balance between matrix synthesis, degradation, and resorption may become imbalanced, further contributing to the fibrotic process. The injured epithelium is unable to restore itself and becomes vulnerable to apoptosis or programmed cell death. In addition, the now exposed underlying basement membrane becomes disrupted, allowing fibroblasts to infiltrate the alveolar space. Conversely, fibroblasts and myofibroblasts fail to undergo apoptosis, resulting in continuous alveolar invasion and deposition of matrix, contributing to further destruction of normal lung architecture. The disease becomes more extensive due to repeated injury, each at different stages of development throughout the lung. This explains the temporal heterogeneous pattern interspersed with healthy lung tissue and the gradually increasing accumulation of matrix, unremitting fibrosis, fibroblastic foci, and honeycomb cysts that are the hallmark features of idiopathic pulmonary fibrosis. However, as our understanding of the underlying mechanisms of IPF evolves, from that of a disease resulting from chronic inflammation to that of one due to recurrent epithelial cell injury and aberrant fibrotic processes, our treatment approaches are evolving too.